Some terminology that I've used already. When we launch an object through the air, we call it a projectile. Projectiles travel in parabolas. They travel in what we call a parabolic trajectory. It's one of the reasons you look at parabolas so much in high school math, is parabolas show up in nice places in physics. Those that are doing calculus have just started to look at conic sections. Conics show up all over the place in physics, and a parabola is a conic section. We break each projectile's velocity into its vertical and horizontal, or into its horizontal and vertical components. So one thing that you need to be able to do almost in your sleep is, if I give you a slanty velocity, you should be able to break it up into its vertical and horizontal components. So here it looks like we're launching at an angle of 36 degrees above the horizontal at a velocity of 24 meters per second. In our notation, when I'm drawing components in, I do my components as a dotted line to let myself know that's actually not what they gave me, that's something I'm breaking it into. And I do this component as a dotted line. I put arrows on the end of each component so that I can realize which way this is actually moving, up and right in this case. I would call this one Vx. I would call this one Vy. I apologize, it's been too long. Color, 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 color. Now you're happy. Hey, that 24, opposite, adjacent, or hypotenuse. What about Vy? What about Vx? Which one of these should I technically put an initial on? Only one of those three should get an initial on it. Which one? Sorry, only one of the two components should have an initial on it.
VI.
Why Vy and not Vx? Vx is constant, so I'm even going to sneak that in just to remind myself that's my starting velocity for that. Vx, which trig function? Did I not give you a lesson?
Yeah.
Oh, I'm sorry. I gave you one? I didn't give you? I thought I didn't give you one? Sorry, one.
Here. There you go. 24 cosine 36.
Okay. First of all, which trig function is going to be cosine? And if I write it out, it ends up being 24 cosine of 36 degrees. Which trig function is Vy going to be? I think it's going to be sine, and I think it's going to end up being the same thing. It's going to be sine 36 equals Vy initial over 24. It's going to end up being 24 sine 36 degrees. So one nice thing is there's some nice symmetry going on here, Maggie, at least. I mean, you can choose to memorize stuff if you want to, but even if you don't memorize it, you'll know you're right because, they look similar. I probably set this up right. Some key ideas, when we get closer to your test, if you're looking for a page that you want to look at when you're studying, it would be this page. It would be these two boxes. I'm going to zoom into the horizontal side first of all. Horizontal motion, Vx is constant. That means that Ax is 0, which means that horizontally d equals Vit plus a half At squared just becomes dx equals Vxt. That's the distance equation, the displacement equation, when you're solving a question horizontally. This means that if you know the time of flight, you can find the horizontal distance. Another word for horizontal distance is range. Oh, by the way, it also means if you know the range, you can find the time of flight. This is the easiest equation to use to solve for t, because there's no squareds or anything like that. Vertically, Vy changes, but Ay is constant. It's negative 9.8 meters per second squared. I had somebody on my YouTube channel yesterday ask me why I don't use negative 9.81 instead of negative 9.8. And so I had to get nerd trivia on him. It varies from place to place on the Earth depending on how dense the ground is underneath you. It varies from negative 9.8 U1L7 something 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 down to when you're by the equator, because the Earth bulges out at the equator, which means you're a little further from the center of the Earth, which means gravity's a tiny bit weaker. I think on the equator it's 9.79 something something. So we typically use a 9.8, close enough. But gravity does vary from place to place on the Earth. We can detect that. That's how, as I understand it, when NASA is using satellites and finding underground lake beds and things like that, they're actually detecting the change in the gravitational field right there, because rock is denser than water, and so if it was all rock, there would be a slightly higher gravitational field at that location. Hashtag nerd trivia. So because A is not 0, vertical distance, dy, is VIYT plus a half A. Let's even put a little y right there, t squared. If Vy initial is 0, like when we launched horizontally from a cliff, then don't write this down. We could do that. But if we are at an angle, Vy will never be 0. Vy initial will never be 0, which means, sadly, we might end up with a full quadratic equation with a t and a t squared, and that's going to be today. I saw Adam making a frowny face. No, we get to use the quadratic formula. You're welcome. That's a privilege. Okay. Little note, at the top of its arc for a split second, Vy is 0. Does this mean that the total velocity is 0? If Vy at the top is 0, does this mean we're at rest? No. Vx still, why am I all caps, exists. Oh, maybe because I'm yelling at you. Sure, we'll pretend I'm yelling at you. Also, if we start from the ground, oh boy. If you're starting on the ground and ending on the ground, if you're doing a nice symmetrical path, or actually I can generalize that more, Ben, whenever you're at the same height before and after the top, your Vy up will equal negative Vy down at those locations. That can sometimes be handy. So if we're starting on the ground and ending on the ground, August, Vy initial will be negative Vy final. But actually I can use that trick anytime I'm at the same height on the way up and on the way down, which might come in handy. Last, if you're starting from a cliff from a vertical height, the ground is below you, and this means that your vertical displacement will be negative. Those are the key ideas for projectiles. Let's look at launching from a cliff. Oh, first, I always have somebody who says, Mr. Dueck, you said that projectiles travel in a parabola, but I've seen some projectiles that look like they wobble. What's going on with that? Put your pencils down. Projectiles being launched from a cliff at an angle. Did I say angle? We're going to use components. To find, oh, by the way, we're also going to spend most of our time finding time. If they give you time, Nick, trust me, the question falls apart, because time can go both in the vertical and in the horizontal column. You're going to be fine. But usually I won't give you time. Rowan, you with me? Okay, back here. There are several strategies. One strategy says find the time to the top because Vy at the top is 0. Then start at the top, make Vy initial 0, and find the time to the bottom. Strategy number 2 is do it all at once. Strategy number 3 is find the time to the top. Double it, that gives you the time back to the cliff height, and then starting on the cliff height with negative Vy initial, find the time to the bottom. I don't really recommend that, and honestly, I'm not a big fan of that. Those of you that have had me before know, William, I'm going to do it all at once, but it's probably going to require the quadratic formula, and you'll see why in a second. Although there's a hack workaround. However, if you know how your calculator uses a quadratic solver, you want your calculator out, you want your calculator out, you want your calculator out. You're a loner, but I'll call you a loner. Is that what you said? Okay, that might work. I like example 1, I like example 1, I like example 1. Example 1 is a nice question. Except I have to be honest, I wouldn't ask you to find the time. What is part B asking us to find? Part B is times the top? Really? That's too easy. C, I'd ask you to find C, but we're going to have to find time to do it all. First thing that I would do is I would do a T-table. Because I know I'm going to run out of room, I'm going to put my T-table right here, and I'm going to call this horizontal. I'm going to call this vertical. What two things can I write without even thinking about it because this is a projectile?
Acceleration 0.
Which one?
The x.
AX is 0.
A minus.
AY is negative 9.8. Cole, is there an angle? Components. I'm going to break this velocity into components. So I'm going to break it into Vx and Vy initial. It looks like the hypotenuse is the 50. Vx, opposite or adjacent? Oh, sorry. Color. Vx, opposite or adjacent? Adjacent. Vy. Which trig function am I going to use to find Vy, Brendan? Say that again. You're right.
Sine equation.
Which trig function was Vy up here?
Sine.
Will Vy always be sine? It will be if I draw it in the standard way I've been drawing it with the theta next to the horizontal line. Mr. Dueck, could you give me a dumb way to remember that Vy is sine? Mr. Dueck, is there a clever way that maybe I could just remember as a shortcut that Vy is sine? I got nothing. You'll have to come up with some stupid way on your own to maybe remember that Vy is sine. That doesn't work for the airplanes and the rivers and my other vector questions because I don't always give you the angle in the same place. But for projectiles, we're always going to give you the angles in the same place. Which trig function was Vx?
Cosine.
Of course it is. So I think I can say Vy initial is 50 sine 30. I may use that, but I always type it in because sometimes these work out evenly. This one does. Try 50 sine 30. It should be exactly 25 on your calculator. If it's not, you're in the wrong mode. So you want to double check, okay? So unlike yesterday where I typed, I think it was 100, last lesson, 100 sine 35, and 100 cos 35. Here it's less typing to type the 25. I'm going to do that. Vx is going to be 50 cos 30, which is I would carry extra sig figs. I'd probably go 43.30127 because there's a lovely 0. That seems like a nice place to round off. There's a 0 there too. I could probably get away with 43.3, but I'm going to be using this to find other stuff. So 43.30127. Which, you know what? I'll probably just type 50 cos 30 because that's less typing. Chad, how many pieces of information do I know in the horizontal column? How many do I know in the vertical column? Not enough. So now I'm either going to reason my way. First, I always check the diagram. Is there any other information the diagram gave me, Chad? I already used that. Is there any other information that the diagram, nod your head. Is there any other information that the diagram gave me that I haven't used yet? Yes. What? That's 60. Is it vertical or horizontal? Be obvious. Yeah. Now, the other thing I could have done is instead of giving you the height of the cliff, I could have given you the range. I could have told you how far sideways it went. That makes it way easier. Trust me, you'll do some of those in the homework. But for now, I'm going to put, so they gave me dy. Why am I not going to write dy equals 60? Why would that be wrong? Yeah. So what will I write instead? Pretty good for a rook. I'm impressed, buddy. Nice. Chad, which column do I know 3 things in? I'm going to find time vertically. I'm going to do that here because I know I need lots of room. And I'm going to say t equals question mark. I would now say to myself, I'm looking for an equation that has acceleration, v initial, d, and t in it. There is one. It's our old favorite. Chelsea, which one? Sorry, you looked at me like you knew the answer. Ryan, which one? So I'm going to put the y's at dy equals vy initial t plus a half ay t squared. And sadly, none of these are 0. So I'm going to have to do something that I normally dislike. I have to put in numbers at this stage already. When I do that, I'm going to get negative 60 equals 25t minus 4.9 t squared. I did do half of negative 9.8 in my head. I hope I didn't lose you with that because I can divide any number by 2. What kind of an equation is this? It's a quadratic. How do I know? Because there is a squared. And unfortunately, this is a quadratic that has a squared t and a linear t, so I can't get a t by itself. I've got to solve this like it's a quadratic equation. Now, my international students, you may solve quadratics using something that has p's and q's in it, and if you do it that way and you can get the right answer, fine, great, I'm good with that. Or you may solve something quadratics using something that has a's and b's and c's. If you use that, that's fine as well. It varies from country to country. So,
Really? There's another way to solve quadratics, Mr. Dueck?
yeah, Nick, there is. What's the first thing I have to do to solve a quadratic before I even start? What did you have to do? Who remembers? Pardon me, Adam. Make it equal to 0. Now, here is a Mr. Dueck pet peeve, not in any textbook. Although the easiest way to make this equal to 0 would be to plus the 60 over, I know that I make far more dumb mistakes when the quadratic term is negative. I've just learned over the years. So I'm actually going to plus the 4.9 t squared and minus the 25 t squared because I'm doing it all in my head anyways. So on the next line, I'm going to write positive 4.9 t squared minus 25t minus 60 equals 0. For a candy, can anybody tell me the quadratic formula from memory? Ben. X equals negative b plus minus b squared minus 4ac over 2a. Can anybody say it faster than that? Can you say it backwards? a2 overall. ca 4 minus square b root square minus plus b negative equals x. The quadratic formula, Owen, when I used to teach math, I would say to students, it was the iambic pentameter of mathematics. It was as close as you ever came to poetry in mathematics because it's the only one of its kind. There's a quadratic formula. We've known about the quadratic formula for several hundred years, but once they found the quadratic formula that would solve any x squared equation, the next logical question to ask for mathematicians was, is there a cubic formula? Is there a quartic formula? Is there a quintic formula? Hey, is there one formula like a Sauron ring of power to rule them all and bring them all into solutions? Turns out, no. Took several hundred years. It's only proved about 100 years ago the quadratic formula is the only one of its kind. There are cubic equations formulas that will solve a certain type of cubic equation that looks like this, but not one that looks like this. There's no other one size fits all. So, Ben, you said this. Instead of x equals, I'm going to put t equals because it's a t and I'm pedantic that way. So you said t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I think I gave you that on the back page of your formula sheet. Double check. I think I did. Okay.
Yes.
Although this is one that probably is kind of worth memorizing. As someone who hates making kids memorize stuff, I know when I taught math, I made my kids memorize it. So now I want to be maximum organization for minimum work. William, I don't know how your math teacher taught you. They might have taught you to write A equals and then B equals and then C equals. I tend to do this. That's A, that's B, and that's C. That was enough for me to figure out what I was doing. So it's going to be, Ethan, what's negative 25? Are you positive? Okay. 25 plus or minus the square root of. You have to be a little bit careful when you're doing b squared. Can everyone look up? On your calculator, if you go negative 25 squared, your calculator doesn't know that you wanted it to square the negative. It'll leave the negative in front. So if you're ever squaring a negative, like this, you would have to go bracket negative 25, close bracket squared. Type that into your calculator, all of you, and don't hit equals. I would write negative 25 in brackets squared minus 4 times A, 4.9 times C, negative 60. I would write that on my all over 2A, which is 9.8. On my calculator, what I typically did, I did the inside of the square root first. So I would, on my calculator, go negative 25 squared minus 4 times 4.9 times negative 60 equals, and I would say, okay, this is 25 plus or minus the square root of 1801 over 9.8. And I would write that down. 25 plus or minus the square root of 1801 all over 9.8. And then I would get both roots. This is a fraction, so brackets around the top. I would go bracket 25 plus the square root of 1801, close off the square root, close off the top, divided by 9.8. One of my roots is 6.88144799. You know what? I'm probably going to go to that 7. Since there's two 9s, I'll make that 7 and 8. 6.881448. Then in math, you were also told to put a minus sign there. I get negative 1.779. In math, you would have kept that. In physics, since we're finding physical concepts, can time be negative? So I'll write it just in my notes, negative 1.779. But then I'll do that. Reject it. Reject, like Ryan trying to dunk. Reject. Okay. So they wanted the time. Time is 6.88 seconds. I'll put a box around that answer, but I've got a longer time if I need to use it. Now, I'm going to pause the video, and we're going to see if you have a quadratic solver. All right. That's the total time of flight. So that would be the time to go from here to there. Don't draw that in necessarily because it wrecks your diagram, but just to let you know what we found. Mr. Dueck, what's that negative t value that we got? Oh, that would be if instead of moving up and right at 50 meters per second, if you're moving that way at 50 meters per second and could somehow magically travel into the ground, it would take you 1.779 seconds to get back to 0 over here. It actually does mean something, but it's kind of useless. Erase that. B, time to top. Top, vertical or horizontal? Vertical. What do I know, Ryan, about being at the top? So time to top, we can still go Vy final is 0. Have you turned the page? Okay, so you still have all your data. I've turned the page, so I'm going to quickly relist AY equals negative 9.8. VY initial was 25. I can find T from that. Oh, yeah, I can find this. I think it was Owen that gave us the equation last time, but I can't remember. VF equals VI plus AT, and then get the T by itself. It's going to be T equals VF minus VI over A. Just make sure you're using vertical values in this equation. And so it's going to be 0 minus 25 all over. VY initial was 25, right? Yep. All over negative 9.8. Zero minus 25 all over negative 9.8. I do get a positive time. To get to the top, 2.551 seconds. 2.55 since they wanted an answer. I'm not going to reuse this. Probably what I would ask you on a test is I would simply say find the range. And the range will be horizontal or vertical. That's the horizontal distance. So again, I've kind of scrolled down. You still have this, but you would say this is asking us to find dx. What was ax? What was vx? Whatever 100 cos 50 was. No, not 100 cos. Whatever 50 cos 30 was. I knew there was a 50 in there somewhere. Problem, I only have two things. How can I solve this horizontal? Wait. What did I find, Matt, in part A? And time is a scalar. It can go in both columns. So I'm going to use, although I wrote 6.88, I'm either going to use my answer button if I happen to have this stored, or I'm going to use that. Those of you that have the built-in solvers, you can play around with, it may actually store those roots in letters on your calculator. If you go alpha X or alpha Y, you might find, oh, it's stored it in there if you just hit equals and see what it displays. That's going to vary from calculator to calculator, and that I can't predict. Anyways, I'm going to say this. dx equals vxt. What happened to the plus a half at squared? So it's going to be 50 cos 30 times 6.881448. $50 cos 30, close off the bracket, times 6.881448. And I get 297.9, you know what? 298 meters. I would consider part C a B plus, A minus level question. I guarantee you're going to see that in the future. I like part C. I like, you know what? Part C, will you marry me? That's how much I like it. Okay. Okay, Mr. Dueck, if that's like an A minus, what's an A level? D. D. Oscar, what does D want me to find? No. Read exactly what it says to me, please. What's the impact velocity? Not zero, and please stop doing that. Those the other thing.
Isn't it zero?
Again, do a belly flop off of a cliff onto some pavement. I assure you, it will hurt. It won't be zero. I'm going to dulp. What does dulp stand for? Now, here's my argument. Look up. I'm going to argue when we hit the ground, I can tell you what the impact velocity looks like. I think it looks like that. It might be a bit steeper. It might be a bit shallower, but I'm telling you we're hitting the ground at an angle. Did I say angle? Okay. So this is what they want me to find, and you're right, Oscar. Now I'll call it VF. That's what they want me to find. I think, though, I'm going to break it up into a a Vx and a Vy, but this Vy is a Vy final. Wait a minute, Vx I already know. That's going to be 50 cos 30. I'll put the decimal value in there. That's going to be 43.30127. Is Vy final negative 25?
Yes.
Why isn't it negative 25?
Because it starts from 60.
Ah, we're at a different height. By the way, Vy final would be negative 25 right when we get to that level again. Right there for a split second. When we're at level with the cliff again, it's negative 25. But then it's going to be, in fact, I'm even going to tell you it's going to be larger than negative 25 if we're talking about the magnitude. So I need to find Vy final. Is this vertical or horizontal? Vy final. So I'm going to make a little note here, Mackenzie. You probably still have it on the page. I know that. I know Vy initial. That was 25. That's only two things. There must be a third thing that I know. So I can find the fourth. That's horizontal, not going to help me. Could use this. Or I could use 6.881448. Now, time is much more convenient to use here. The only risk is if I got time wrong, I'm getting this wrong. This is physics 12. We're going to roll the dice and pick an easier way, even if it means we're using data that we've already calculated. So, and the nice thing is this gives us an equation where Vy final is by itself already. It's going to be Vy initial plus Ayt. $25 plus negative 9.8 times 6.881448. I should get a negative answer here. I hope. I do. Negative 42.4382. So I can add that to my diagram. In my diagram, I'm not going to put the negative in front of the number. The arrow pointing down, that's the negative, taken care of already. So I'm just going to put 42.4382. Now what? Well, I guess V final is going to be the resultant. I've added these two vectors tip to tail. How will I find the magnitude of the impact velocity? Yep. V final is going to be as a magnitude. Oh, you know what? I have this number on my calculator conveniently, so it's going to be this number squared plus 43.30127 squared, square root 60.6 meters per second. But all vectors have magnitude and direction. Where's theta going to go? Top left or bottom right? Where the vector is coming from. Color, 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 color. Which trig function to find theta? I think I would probably go with opposite and adjacent. I think I would go with tangent. Look up for a second. I can already tell you what the answer is almost in my head, Ben, just because this is 42.4, this is 43.3. These are almost the same length. This is almost an isosceles triangle. We're going to be really close to 45 degrees. I'm going to guess either 44 or 46. Probably. Anyways, let's solve it. So we're going to go tan theta equals opposite 42.4382 over adjacent 43.30127. $42.4382 divided by 43.30127. 44.4, which is about what I said it would be. Yeah, quick look at money. At 44.4 degrees north of south, east of west, what of what? Well, it's not north or south, because up is not north and down is not south. We would say this is below the horizontal. If it was on its way up, we would say it's above the horizontal. That's the physics speak for pointing downwards from a horizontal line, hitting the ground downwards at an angle. Okay. Example 2 is an identical example to example 1. I just changed the numbers. I said, oh, find the flight time, find the range. We're going to skip example 2, and we're going to go to, boy, I'm looking at my clock here. How am I going to do this, Mr. Dueck? I want to get a few more in, right, Mr. D? Okay. I think right now, even though I've only done one example, I'm hoping you can kind of use that as a template. So I am going to pause here. If you want to get a start on this for the remaining 10 minutes or so, I am going to assign all of question number 1. I would do these on a separate piece of paper if I were you. So there's 5 questions where you have a different height, a different theta, and a different slanty velocity. It's going to have to find time using the quadratic formula, and then find the range. I think that's going to be your homework to start out, but I'm going to continue with this next class. Okay?